applied qualitative analysis. And what we're going to do is we're going to look at an experiment, and this next lab, which ends up taking 4 lab periods, is going to be solely graded on if you can identify 6 cations in the solution. You're going to have 3 lab periods to play around and kind of discover various things about solubility. But this lab can be an awesome tool to really teach the underlying concepts of solubility. So a qualitative analysis scheme is designed to answer what is present. It doesn't really say anything about the amount. It's answering a question, yes or no. Is a particular ion present in solution? And what you find is when you look at this qualitative analysis schemes, we put the ions or the cations into groups. And what we can say about that is that we group cations based on solubility characteristics. And if you look in the textbook at the end of chapter 17, you'll see that we typically have roughly 5 groups. Group 1 contains 3 cations. Those 3 cations are silver plus, lead 2 plus, and mercury 2 plus, which is Hg 2 plus. In terms of all the cations, these are the most insoluble, and this group will precipitate with chlorides. And these are kind of the exceptions to the solubility rule, because silver, lead, and mercury will precipitate out with just about anything. So we put them into group 1. In your typical laboratory scheme, we've taken out mercury, and it's rarely ever used in chemistry labs in the year 2011 because of its toxicity. But if your grandparents came to school at Ohio State, they got to play with mercury in labs. So it's one of the things that is still included in the scheme, and I would expect you to know this, and I'll give you some tips based on the KSP tables of how to isolate these guys out. The next group is group 2, and there aren't any fancy names for these things, just Roman numerals. And in group 2, we have bismuth 3 plus, copper 2 plus, antimony 5 plus, tin 4 plus, trace amounts of lead 2 plus, and mercury 2 plus, cadmium 2 plus, and arsenic 5 plus. Again, for the same reasons we usually remove the mercury from our laboratory, we're also going to take out cadmium and arsenic because they're also very, very toxic. The differentiation for group 2 and all the other cations is that these cations will precipitate as sulfides under acidic conditions. So if we add sulfide or a reagent that could potentially produce a sulfide precipitate, the group 2 ions then would precipitate out. Group 3 contains iron 2 plus, aluminum 3 plus, chromium 3 plus, cobalt 2 plus, zinc 2 plus, and manganese 2 plus. These differ from the group 2 ions because these precipitate as sulfides under basic conditions. So if we adjust the pH, we can selectively precipitate out or separate the group 2 and the group 3 ions. Group 4 contains barium 2 plus, calcium 2 plus, and magnesium 2 plus. These 3 cations right here will precipitate with the phosphate ion. And lastly, in group 5, we have sodium plus, potassium plus, and NH4 plus. This is the soluble group. And it's really, really tough to precipitate these ions out in solution. So what we have to use is something called a flame test. And that will be able to allow us to identify whether those 3 ions are either present or if they're absent. As we go through this scheme, there's one theme that I really want to touch upon. And that is we're going to be doing 2 particular, tactics here to separate these ions and identify them. The first thing that we're going to do is we're going to isolate. Unfortunately, when we go through the qual scheme, there's no one test that we're able to do for a whole, solution full of ions. We can confirm the presence of a particular ion, just like House did, where he got that bright purple color on the one lady's hands. But we have to first isolate that out. And a lot of the times, students want to ignore the first step and go right to the second step, which is confirmation. These 2 steps right here are of equal importance. And what I mean by that is the following. In order for a confirmation test to be effective, you can only have 1 ion in solution. So if you didn't do a great job of separating in the initial steps, your confirmation test could show up as a false positive. So you must be able to isolate all the ions before you can confirm that they're present. And I'm going to go through the examples of that as we go through this scheme that we're going to be using in this week's lab. So what we've done is we've taken all of these ions that we have here and selectively chose a couple of them for you guys to analyze in lab. So you're going to go into lab and you're going to get an unknown. This unknown can contain 1 to 6 cations. And the 6 cations that we're going to look at are silver plus, lead 2 plus, bismuth 3 plus, copper 2 plus, aluminum 3 plus, and nickel 2 plus. And the unknown that you're going to receive is going to be a solution. So the first step that you're going to use is you're going to get a test tube. with a solution of all 6 of these cations. And these are the only 6 cations that we're going to analyze in this particular lab. So when I say your unknown can contain 1 to 6, you could have any one of these 6 right here, but there's going to be no other cations. Like sodium and barium aren't in there, mercury's not in there. These are the 6 that you're going to analyze. So we're first going to give you a known solution and tell you to go around and play and observe. The narrative for this particular lab is very, very, very important because you have to be able to write down the colors that you observe. So for example, if you mix 2 solutions together and it will say you're going to observe a precipitate, be sure to note the color, you need to be able to write that down in your notebook so when you see that again, you'll be able to identify the same thing. Okay? After your 3 labs, you're going to get a lab practical. And that lab practical is going to be the unknown. So make sure in this particular lab you keep very, very good observations. The first step that we're going to do in this analysis is we're going to add cold dilute HCl. And when we add this, we're going to observe a precipitate form. So down here at the bottom of the test tube, we're going to get a white precipitate. And that white precipitate is going to be silver chloride plus lead chloride. And lead chloride is PbCl2. In solution, we're still going to have bismuth 3+, copper 2+, aluminum 3+, and nickel 2+. So this is an effective separation to remove silver and lead from solution. And we can say that up top here, we're going to call this solution 1. And down here at the bottom, I'll call this precipitate 1. And what this is accomplishing is it is separating silver and lead from the other ions. Just like we talked about fractional precipitation, where sometimes we'll add a particular reagent and we'll get a precipitate in one case, but then there'll be ions in solution in another case. There's a way to be able to predict this. And even if you didn't know anything about a qualitative analysis scheme, what I want you to be able to do is know where to look to figure out what the precipitate would be. So if we look in the textbook and we look at table 4.1, this is called the solubility guidelines. And in the solubility guidelines, it's going to tell us that chloride ions are soluble. But there's going to be exceptions. And those exceptions are silver plus, lead 2+, and mercury 2+. So even though we're not talking about mercury right here, if you can learn the thought process that's going on behind here, you can be able to identify any type of ion and whether it will precipitate or whether it will not precipitate.